Okay, off to question number 15. So in the diagram, P, Q, R, S, T lie on the circle. QT is the diameter. So QT is the diameter, which makes this angle 90 degrees. So let's mark it as 90. Okay. X is the point of intersection of PS and QT. So PS and QT intersect at X. PXT is 125, PSQ is 35 degrees. Complete the following statement with a geometrical reason. PTQ, PTQ. So this angle basically. They're saying that it is 35 and you need to give a reason for it. And I hope all of us are able to do that. So basically, PSQ and PTQ are angles made in the same segment, right? So angles in the same segment are equal. So see, this is the chord PQ. So the angle made at the circumference from the ends of this chord, so it is 35 degrees, right? And see this same chord, look at the ends of the same chord. They're making an angle of PTQ. So basically, because angles in the same segment are equal, so PTQ is also going to be 35 degrees. Okay? Okay. Because angles in the same segment are equal. Okay, and let's see if it is the reason, exact reason that is listed in the syllabus. So this angles in the same segment are equal. Okay. Next, they're asking us to find PQT. Okay, so let's erase this. P, Q, T. They want us to find this angle. This angle. And we know that this is 90. So let's focus on triangle PTQ. We know this is 90. We know this is 35. We can very easily find angle PQT. Okay. So 90 plus 35 plus angle PQT should add up to 180. So angle PQT is 180 minus 125, which gives you 55 degrees. Okay, so this is 55 degrees. Next, they want us to find angle SPQ. So SPQ, this angle, all right? So we know that this is 90. If we can find this small angle, we can just subtract this angle from 90 to find SPQ. Okay, so let's focus on triangle PTX. We know this is 125 and this is 35, so we can calculate this angle. So this angle would be 35 plus 125 plus, let's call it theta for now. All of these should add up to 180, so theta is going to be 180 minus 160, so theta is 20. So if this is 20 and this entire angle is 90, all we have to do is subtract 20 from 90, which gives us 70. So angle SPQ is 70. Okay, find SRQ. SRQ, this angle. All right, so SRQ. Okay, for that, I want you to focus on the quadrilateral PSRQ. Okay, or PQRS, better. All 4 points are on the circumference, so PQRS qualifies as a quadrilateral, cyclic quadrilateral. Okay, and what is the property? That the opposite interior angles of a cyclic quadrilateral are supplementary. So basically this plus this angle should give us 180. Okay, so 70 plus SR angle SRQ should be 180. So angle SRQ is 180 minus 70 degrees, which gives it to be 110 degrees. Okay. Okay, A, B, C are points on the circumference. A, B, C are points on the circumference of a circle with center O. Since this is the radius, this will be 90 degrees, right? So let's mark that out right now. So this is going to be 90. Okay, O is the midpoint of BC. All right, yeah, so this is the diameter and this is the midpoint. ABC is 38 degrees. Tangents are drawn from T to touch the circle at A and B. So tangents made from an external point are equal. So these two are going to be AT is going to be equal to BT. Calculate BCA. BCA. Okay, so this angle. This is pretty simple because if we focus on triangle ACB, we know that this is 38 and this is 90. We can calculate angle BCA. So 90 plus 38 plus angle BCA should give us 180 because sum of interior angles of a triangle is 180, right? So angle BCA is equals to 180 minus 128. So angle BCA is equals to 52 degrees. Okay, next they want us to calculate angle ATB. ATB, this angle. So they want us to find this angle. Okay, so how are we going to do that? Okay, so we know that a radius and tangent, they make a 90-degree angle, right? So let's mark this as 90 as well. So if this is 90 and this is 38, this would be 90 minus 38, right? So this angle would be 52 degrees. And because this is an isosceles triangle, if this is 52, this would be 52 as well. So this is 52. So now I think we can very easily figure out ATB if we focus on the triangle ATB. So 52, 52, and ATB should be 180. So 52 degrees plus 52 degrees plus angle ATB should be equal to 180 degrees. So angle ATB is 180 minus 104. So angle ATB comes out to be 76 degrees. Okay, so the diagram shows a circle with center O that passes through A, B, C, D. The tangents at A and B meet at T. So these two will be equal. Tangents drawn from an external point to the circle are equal. Alright, find X. This one is pretty simple. We will focus on the arc BD. So the angle subtended by the arc at the center is X, and the arc extends an angle of 53 at the circumference. So basically the angle at the center is twice the angle at the circumference. So all we have to do is multiply 53 by 2 to get 106 as your answer. Okay, so X is 106 degrees. Find Y. Okay, I hope all of us can see the cyclic quadrilateral A, B, C, D. All 4 points are on the circumference. And we know that this is 53. So 53 plus Y should be 180 because the opposite interior angles of a cyclic quadrilateral are supplementary. Okay, so 53 degrees plus Y is equals to 180. So Y is going to be 180 minus 53, which gives out Y as 127 degrees. Okay, now they want us to find angle Z. We know that ATB is an isosceles triangle. So this is 62, this is Z, this would also be Z, right? So let's mark it as Z. And therefore we know that Z plus 62 should be 180. So 2Z is equals to 180 minus 62. So Z is going to be divided by 2, which gives you Z as 59 degrees. Okay, and last, okay, so this is 59. This is also 59. Y is 127. Okay, now they want us to find angle T. Okay, so we know that a radius and tangent make a 90-degree angle. So this is 90. And we know out of 90, this is 59. So Z plus T is basically 90, right? So we also know the value of Z, which is 59. So Z plus T is equals to 90 degrees. Why? Because OB is the radius, BT is the tangent. So the radius and tangent meet at 90-degree angle. So Z plus T is 90. We know that Z is 59. So 59 plus T is equals to 90. T is equals to 90 minus 59. So what is the value of T? 31 degrees. Question number 19. A, B, C, D, and E are points on the circumference of a circle. Center O, tangent AF touches the circle at A. O is the midpoint. Okay, so the radius and tangent, they will make a 90-degree angle. Let's mark that right now. This is the diameter. So the diameter is going to make a 90-degree angle. So let's mark this as well. Okay, and let's mark the radius. So this, and this is going to be equal. So all lines originating from the center to the circumference will qualify as the radius. So 1, 2, and 3. These are the 3 radii of the circle. Okay, DOE is 138, BEO is 12 degrees, O is the midpoint of AD. All right, find EAD. So E AD. They want us to find this angle. This angle. Okay, so let's see. We know that AOE is an isosceles triangle, right? So this angle and this angle is going to be equal. So let's mark this with green as well. And let's call it theta for now. Okay. And let's focus on triangle AOE. Okay, so theta and theta, is there any way that we can calculate this value? Yes, because see, if this is 138, should this and 138 should add up to 180. Why? Because they're angles made on a straight line, right? So angles on a straight line should add up to 180. So 180 minus 138 gives you 42. So this is 42. Okay. Now let's focus on triangle AEO. So 42 plus theta should be equal to 180 degrees. So 2 theta is equals to 180 minus 42. Theta is 8. So it is going to be 69 degrees. Okay. So angle EAD is 69. Okay. And we know that this angle is 69. So 69 minus 12 gives us 57. So this angle is 57. This angle, which is AEB. Okay, so next they want us to find EAF. EAF. This should be easy because we know that this angle is 90 and this is 69. So 90 minus 69 will give you this remaining angle. So 90 minus 69 gives you 21 degrees. So this is 21 degrees. Okay. 69 plus 29 is 90. Okay, so this is 21 degrees. Find BEA. BEA, we've already found that. BEA is 57 degrees. BCD. So they want us to find BCD. Okay. So let's see. BCD. Okay, see B. So let's focus on the chord AB. So the angle made by the chord AB at E is 57. And the chord AB is making another angle at the circumference at D. So this is also going to be 57, right? So let's mark this as 57. Okay, and they want us to find angle BCD, this angle, right? Okay, so if we find a way to figure out this angle, which we can very easily by focusing on triangle ABD, we can find this angle, and then we're going to focus on the cyclic quadrilateral ABCD, right? So angle A and angle C should add up to 180 because they are the opposite interior angles of a cyclic quadrilateral, which is basically their supplementary angles, right? Okay, so let's figure this angle out. So we're going to focus on triangle ABD. This is 90, this is 57. So we can figure out angle BAD very easily. So 90 okay, so 90 plus 57 plus angle A should be equal to 180, right? So angle A is 180 minus 147, which gives out angle A to be 33 degrees. Okay, so now we know that this angle is 33, and now we're going to focus on the cyclic quadrilateral ABCD. Angle A, which is 33, and angle C are supplementary. So angle C plus 33 should be equal to 180, which gives us angle C as 180 minus 33 degrees, which is basically 147. Okay, so angle BCD is 147 degrees. Okay, so in the diagram, points A, B, C, D, and E lie on the circle with center O. Okay, so this is the diameter, which makes this angle as 90 degrees. Let's mark it. Okay, mark it as 90 degrees. The points B, O, E lie on a straight line. So this is a straight line. AB is parallel to ED. AB is parallel to ED. Be ready to use some properties of parallel lines. And there's one that I can see instantly. So alternate angles. Angle Z is going to be 53 because they're alternate angles. So I will just mark it right here. Okay, so they want us to find X. Let's first mark all the radius. So this is the center. All lines originating from the center to the circumference will qualify as the radii of the circle. So this is the radius, radius, radius. Okay. So this tells us that triangle OED is an isosceles triangle. So if this is 53, this will be 53 as well. Okay, and if we focus on triangle ODE, we can also figure out this angle. So two angles of this triangle are equal to 53. So we can figure out the third angle. Let's call this theta for now. So 53 plus 53 plus theta should be equal to 180, which gives theta to be 180 minus 106. So theta is 74 degrees. Okay, so let's write that down. This is 74. And we know that sum of angles on a straight line is also 180. So we're going to find the value of X. We're going to subtract 74 from 180. So 180 minus 74 will give you the value of X. So X comes out to be 106 degrees. Okay, now they want us to find Y. Let's focus on the cyclic quadrilateral BCDE. So if this is 53, Y plus 53 should be 180. Because the opposite interior angles of a cyclic quadrilateral are supplementary. So 53 plus Y should be equal to 180. Y is equals to 180 minus 53 degrees, which gives Y to be 127 degrees. Okay, next I'm sure they want us to find angle Z and T. Okay, so we know that angle Z equals to 53 because they're alternate angles. Now we are left with only one unknown, which is t. We can figure t out very easily as well because we're going to focus on triangle ABE. So one angle is 90, one is 53. We can figure out t. So 90 plus 53 plus t should be equal to 180, right? So t is going to be equal to 180 minus 143. T is 37 degrees. Okay. So let's move on. Z is 53 and T is 37 degrees. Okay. In the diagram, points A, B, C, D lie on the circle with center O. So this is the radii. Let's mark them. Okay. ACB is 69, DCA is 34. Find ABD. ABD. So this angle. I hope that you're now able to see how theorems are being applied. So look at the chord AD. It is making an angle of 34. And it is also making an angle at B. So this is going to be equal to 34. This is the chord. Angles in the same segment are equal. So this angle will be equal to this angle. Same segment. Okay. So angle ABD is going to be 34 degrees because angles in the same segment are equal. Next, you need to find angle AOD. So for that, focus on the arc AD, angle subtended by the arc at the circumference, and angle subtended by the same arc at the center. So the angle at the center is twice the angle made at the circumference. So this is twice the angle made at the circumference. So all we have to do is multiply 34 by 2 to get the value of AOD, which will be 68 degrees. Okay, next they want us to find angle DAB. Let's clear these out. Okay, so this is 34, this is 68, and this is the radii. Okay, they want us to find DAB. Let's mark angle DAB. DAB, okay, this angle. Okay, so for this we are going to focus on the cyclic quadrilateral ABCD. We know that DAB is one angle, and what is the opposite interior angle? It is 34 plus 69. So these two angles should add up to 180, right? So 34 plus 69 plus angle DAB should be equal to 180 degrees. Why? Because the opposite interior angles of a cyclic quadrilateral add up to 180. So angle DAB is equals to 180 minus 103, which gives DAB to be 77 degrees. So DAB is 77 degrees. In the diagram, AC is the diameter. AC is the diameter, which makes this angle 90 degrees. So let's mark it out. This is 90 degrees. With center O, let's mark the radius as well. So all lines, this, this, and this. Okay, the tangents from T touch the circles at B and C. Since the tangents are originating from one external point, CT will be equal to BT. Okay, and if this is an isosceles triangle, if this is 62, this would also be 62. So let's mark this as well. This is 62 degrees. Okay, find x. Okay, so see, this is an isosceles triangle, right? So if this is x, this will be x. So let's mark this as x. Okay. And we know that a radius and tangent make a 90-degree angle. So x plus 62 is going to be 90. Oh, we can apply the same property here as well. So radius, tangent, they make a 90-degree angle. So 62 plus x should be 90 degrees. So 62 plus x should be equal to 90 degrees, which gives out x to be 90 minus 62. X is 28 degrees. Okay? So this is 28 and this is also 28. Okay, next they want us to find y, which is very easy. We will focus on triangle CBT. This is 62, this is 62. So we can very easily figure out y. So 62 plus y should be equal to 180 because the sum of interior angles of a triangle is 180. So y is going to be 180 minus 124 degrees. So y comes out to be 56 degrees. So x is 28 degrees and y is 56 degrees. In the diagram, A, B, C, D, E lie on the circle, center O. So let's mark all the radii, all three lines. So this is the radius. So basically, AOB is 48, DEB is 54, and they want you to find x. Okay, so we know that triangle ABO is an isosceles triangle. So if this is x, this will be x as well. Right, so this is going to be x as well. So 48 plus x should be equal to 180. 2x is 180 minus 48. So x is going to be divided by 2. So x comes out to be 66 degrees. Okay, so x is 66. This will be 66 as well. Next, they want us to find y. Okay, so let's see. Let's focus on the arc BD. So angle subtended by BD at the center of the circle is y, and the angle subtended by BD at the circumference is 54. Right? So angle at the center is twice the angle at the circumference. So if this is 54, we're just going to multiply 54 by 2 to get the center angle. So y is going to be 54 into 2, which gives y to be 108 degrees. Okay, so this is going to be 108 degrees. Now they want us to figure out z. Okay, so if we focus on the cyclic quadrilateral BCDE, so all 4 points are on the circumference, and we know that the opposite interior angles are supplementary. So 54 plus z should be 180. All right. So 54 plus z should be equal to 180 degrees. So z comes out to be 180 minus 54. So we have Z as 126. In the diagram, the circles with center O and Q touch at P. So the circles touch at P, where OPQ is a straight line. The line ORT intersects the small circle at R and is tangent to the larger circle. Okay. So Q is the center of the larger circle, while O is the center of the smaller circle. So then therefore, QT is the radius of the large circle, and since OT is the tangent, this is the radius, this would be a 90-degree angle. Let's mark it out right now. Okay. OR is 4, RT is 6. The radius of the larger circle is x centimeters. Calculate the value of x. Okay, so let's see. We know that since OR is 4, OP will also be 4, the radius of the circle. And since QT is x, QP is also going to be x. Okay, because it is the radius of the larger circle. So QT and QP are the radii. They will be equal. So this will be equal to x and x. This is 4 and 4. Now let's focus on the right angle triangle OTQ. Okay, so this side is 10. This is x and this is 4 plus x. And we need to find the value of x. So what are we going to do? We're going to apply Pythagoras theorem. All you need to do is figure out the hypotenuse. So the length opposite to the right angle qualifies as the hypotenuse, right? So this is h. This is a and b. What is Pythagoras? So Pythagoras tells us that h square is equals to a square plus b square. H is 4 plus x. Whole square is equals to what is a is 10 square plus b is x square. Okay, so let's simplify. 16 plus 8x plus x square is equals to 100 plus x square. So let's move all the terms to x terms to the left hand side and all the constants to the right hand side. Okay, so 8x plus x square, we take this x square to the other side, minus x square. 100 minus 16, this gets cancelled out. 8x is equals to 4x is going to be 84 divided by 8, which gives out x to be 10.5 centimeters. And we'll look at the marks. It is a 4-mark questions. A 4-mark question, not very difficult. All you had to do was figure out small details. So sometimes students are not able to judge that they're required to apply Pythagoras. They keep thinking of applying circle theorems here. But please remember that with maths, a lot of topics overlap and they're combined together, mixed together, tested together. Okay, so be ready to think outside the box. Okay, so A, B, C, D lie on a circle with center O. This is the center. I can see angle made at the center and the circumference already. Radius and tangent, they make a 90-degree angle. So I will mark that out right now. Okay. Find the value of x. So if we can figure out this angle, which we can, if we focus on triangle BOQ, So let's figure out this angle. Let's call it theta. So 90 plus 36 plus theta should be equal to 180. So theta is 180 minus 126. Theta is going to be 54 degrees. All right. So let's mark this as 54. And as already seen, the angle subtended by the arc BC at the center is 54. And that subtended at the circumference is x. So angle at the center is twice the angle at the circumference. So all we have to do is divide 54 by 2 to find the value of x. So that is going to be 27 degrees. So angle x is 27 degrees. B, D, E, F, and G are points on the circumference of a circle with radius, with center O. AC is tangent to the circle at B. So this is AC, tangent to the circle. Okay. Angle DFG, DFG is 75. ABG is 48. Find angle DE, DEG. So you have to find this angle. Right, let's mark the radius. So these are the radii of the circle. Okay, so let's have a look at this chord GD. So angle made by chord GD at the circumference. So this is 75. And then they're also making an angle at E. So angle F and E, they're going to be equal. Why? Because angles made in the same segment. So 75 and this angle. So angle DEG is going to be 75 degrees using the property angles made in the same segment. Okay, find angle DOG. DOG. Again, I would say very simple. Let's focus on arc DG. So angle subtended by the arc at the center is twice the angle subtended by the same arc at the circumference. So all you have to do is multiply 75 by 2 to get angle DOG. Okay? So that is going to be 150 degrees. Find DBC. So angle DBC. They want us to figure this angle out. So let's just make our diagram a little more neat. Okay, so they want us to find this angle, DBC. Okay, so we know that angle on a straight line add up to 180. We know this is 48. If we can figure this out, we can very easily find the required angle, which is DBC. So we are going to focus on the cyclic quadrilateral BDFG. Okay, so if this is 75, so angle B and 75 should add up to 180. So 75 plus angle B should be equal to 180 degrees. So angle B is 180 minus 75, which gives it to be 105. So this is 105 degrees. Okay, so now we can easily figure out this angle. So 48 plus 105 plus angle DBC should be equal to 180 degrees. So DBC is 180 minus 153. So basically 48 plus 105 plus DBC should be equal to 180, right? Angles on the straight line add up to 180. So we have DBC as 27 degrees. Question number 27. A, B, C, and D are points on the circle with center O. So this is the center. This would be the radius then. 0, OA and OB. Okay, let's mark it as the radius. Okay. I hope you can also see that the arc AB is making an angle at the center and then one at the circumference. So we know that the angle at the center is twice the angle at the circumference, right? So if this is 70, this would be 35, half of 70. Okay, one common mistake that a lot of students end up doing is that they assume that this is the diameter and therefore this angle is 90, but that is not the case. The diameter must pass through the center. This line is not passing through the center is here. Okay, so we do not have a diameter here. Okay, so find ADB. So they want us to find angle ADB. Okay, great. So we have already evaluated that to be 35 degrees because angle made at the center is twice the angle at the circumference. Angle basically subtended by the same arc. So AB, look at the ends of the arc. AB is making an angle of 70 at the center, and then again the same ends are making an angle of 35 or half of what is at the center at the circumference, which is point D. Okay, next find BCD. BCD. Okay, so this angle, as already clarified, this is not 90 degrees. Okay, so let's see. We have a cyclic quadrilateral ABCD. Okay, and we know that the opposite interior angles of a cyclic quadrilateral are supplementary, which means this angle plus this angle will give us 180. Okay, so in order to find this angle, I think if we can evaluate or find out this angle by any way, it would make our life easier. And I think it's very easy to calculate this angle. Let's focus on the triangle OAB. It is an isosceles triangle, which means this angle and this angle is equal. Okay, so 70 plus, let's call it x plus x plus x should be 180. Why? Because the sum of interior angles of a triangle is 180. So we have 2x is equals to 180 minus 70. X is equals to 110 divided by 2. So x is going to be 55 degrees. Okay, so we know that this is 55, which means this angle collectively is 80 degrees. Okay, so let's utilize the cyclic quadrilateral property now. So basically angle C and angle A should add up to 180. So 80 plus angle C should be 180. So angle C is going to be 180 minus 80, giving us angle BCD as 100 degrees. Okay, so angle BCD is 100 degrees. Okay, question number 28. B, C, and D are points on the circumference of a circle. B, C, and D. Okay. AB is tangent to the circle at B. AB is tangent. BD is the diameter. Okay, so if BD is the diameter, this would be 90. right? PT, diameter, angle made in the semicircle is 90 degrees. Okay, and since this is the center, this would also be the radius of the circle, right? So the radius and the tangent, they meet at 90 degrees as well. So let's mark this as 90 as well. Okay. Which lines are originating from the origin other than OB? So it's OC and OD. So all of these are the radii. Let's mark the radii. Okay. CBD is x degrees. Find an expression in terms of x for each of the following. Write each expression in its simplest form. So we're not going to forget that they want us to give the answer in simplest form. Okay, so the first angle is COB. COB. So this angle, let's mark it. I hope that all of you are now able to identify that arc BC is subtending an angle at the center and an angle at the circumference, right? So if the angle at circumference is x, you know that the angle made at the center is twice the angle made at the circumference, right? So this is going to be 2x. Okay, so arc BC, look at the ends of the arc, making an angle at the center, and the same ends are making an angle at the circumference. So if this is x, the double of this quantity or value would be the angle made at the center. So it's going to be 2x. Okay, so COB is going to be 2x degrees. Okay, OAB. OAB. I think this is also pretty simple. If we focus on the triangle OAB, we know this is 90, this is 2x. So let's call this angle for now. Let's call it theta. So 90 plus 2x plus theta should be equal to 180 degrees. So theta is 180 minus 90 minus 2x. So theta is going to be 90 minus 2x degrees. Okay, 90 minus 2x degrees. Then they want us to find CBO. CBO. Okay, so let's mark this angle basically. Okay, for that we're going to focus on triangle OCB. You know it is an isosceles triangle. So this angle will be equal to this angle. Let's call it y for now. So we know that 2x plus y should be equal to 180 degrees. 2y is equals to 180 minus 2x. So y is going to be 180 minus 2x divided by 2, which gives us the expression 180 over 2 minus 2x over 2. Let's cancel out the 2's. So what is the final expression that we have? It is 90 minus x degrees. Okay, off to the last question. The diagram shows a circle with center O. A straight line touches the circle. Straight line touches the circle. Complete each label with the correct mathematical name. A radius has been labeled for you. Okay, so very basic key vocabulary terms. I have a video especially focusing on these key terms. So if you have any confusions, please have a look at it. A line touching the circle is known as a tangent. And this shaded region is known as the sector. Minor sector to be precise. Okay? And that brings us to the end of all the Workbook 1 questions from 2012 to 2023. I completed all of them without a calculator, just like you'll face in the actual non calculator paper. So I hope going through these solutions has helped you understand how to apply the theorems more confidently and clearly. I wish you all the very best for your exams. May you ace them with flying colors. Good luck and keep practicing.